In the previous section, we were looking at the graphs of polynomials, and the first step on those was to find the x-intercepts, or the zeros. So we're going to kind of continue with that theme for the next couple of sections, looking at the zeros of polynomials. And one important tool that we have when finding the zeros is factoring, and something that can help us to factor is actually division. And first we're going to start with long division. Luckily, when we're talking about roots, if we have a factor like x minus 6, there's a process called synthetic division that's a little easier that we'll look at. But if your term is not linear, if your divisor is not linear, you have to use long division. I put up here long division of numbers to kind of remind you how that works, and long division of polynomials basically works the same way. So if we want to divide, say, 6 into this large number here, we focus first on the front digit, just on the thousands place. And with the numbers, we have place value going for us. With polynomials, we have the powers that kind of serve like place value. But you divide 6 into 7, and it'll go one time, and then 1 times 6 is 6, and we subtract and see that there's 1 left over. That's really 1,000, but we just use the place value, and we have the 1, and we drop down the next digit to keep going. So we divide 6 into 19. Well, it'll go 3 times and give me 18. 3 times 6 is 18. Subtract, we have 1 left over. Drop down the 5 so that we can keep going. And you repeat that process until you get to the bottom where you have a 2, and 6 won't divide into 2. We've made it to the remainder. And we can write that 7,952 is equal to 1,325 plus my remainder over the divisor. Okay, so we can do a similar thing to do long division of polynomials. We don't have place value, but instead we have the powers of the polynomials, and we want to put them in descending order when we do this, from largest power down for the divisor and the one we're dividing into, the dividend. So what I do when they're in descending order, we just divide the x into x cubed here. You take the leading term into the leading term here to get started. So I'm going to divide x into x to the third, and I get x squared. So that's the first part of my quotient. I write that down, and then I multiply x squared times my entire divisor here, x minus 6, which will give me x to the third minus 6x squared. And then just like with the numbers, I subtract and see what's left over. So x to the third minus x to the third is 0, and I have negative 3x squared minus, we'll make this a plus 6x squared. So negative 3 plus 6 gives me positive 3x squared. And then we could bring down the x plus 7, or we just need to bring down the plus x to keep going for now. You can always, you're really subtracting, and you have all these terms left out here, but we usually just bring down the next one to keep going. And then you repeat the process. Divide x into 3x squared, okay, which would be 3x. Put that into the quotient. 3x times x will give me x squared, and then 3x times minus 6 will give me minus 18x. Subtract and see what's left over. So these two, by design here, subtract off to give me 0, and then we have x minus a negative 18x will give me 19x. It's 1x minus a minus becomes a plus 18. And then we still have the 7 out there. And we go another step. We divide x into 19x. We get 19. And this is going to be the entire quotient now, and we're going to get the remainder. So we do 19 times x minus 6 gives me 19x minus 6 times 19 is 114. Subtract, and we have our remainder now. Once we get down, when you do long division of polynomials, whenever you get to something that's degree is less than a divisor, you've got the remainder here. So we had a degree 1 divisor, we have a degree 0 remainder here, a constant. And so 7 minus negative 114 gives me 121, the remainder. Okay. So that's how long division works. Like long divisions of numbers, it's not the funnest thing to do. It's kind of tedious. But it's a process we need to know how to do, and we just take our time and do it carefully. And again, you can write, so on the answers to these, you could express your quotient as x squared plus 3x plus 19. Your remainder is 121. If you ask, what is x cubed minus 3x squared plus x plus 7 divided by x minus 6, the answer would be my quotient plus my remainder over my divisor. Because if I were to multiply that by x minus 6, I would get what we call the dividend, x cubed minus 3x squared plus x plus 7. So the answer to the division as a single answer is your quotient plus your remainder over your divisor. We have this thing, they call it the division algorithm, which basically just states we can always do this. We can divide and find a quotient and a remainder. And one important part of it that's useful in doing some proofs is that your remainder will always have a degree less than your divisor. Your remainder will either be 0 or have degree less than your divisor. Okay? And the names of those things, if you're dividing D into P here, D is called the divisor, P is called the dividend, and then of course Q is your quotient and R is your remainder. When you divide with a remainder of 0, your quotient times your divisor gives you your polynomial.